Going to chair this next section. So back to you.
Thanks, John, and good morning. So I just want to say just a couple of words about CCG programmed research. I think John has already mentioned a little bit about this, but just to maybe go into much more detail, just because a lot of people in the room are associated with CCG and FCDO are here. So it's good to have this in context of how we're thinking about this and how critical minerals fits into the overall programmed research program that we have. So this is the sort of main slide. So essentially, this is how we see ourselves in programmed research. So just to back up a little bit, I think John mentioned that CCG is more than just programmed research. So it includes a section on research, a section on international partnerships, and a section on country partnerships. And those three kind of legs of the program work together to try and achieve the aims of the program overall. But we have this part, programmed research, which is more deep dive, long-term knowledge product building, evidence building activity, which sits at the core of CCG and produces the products, which are then used for impact by international partnerships and by country partnerships in collaboration with ourselves. But you need that core, you need that deep understanding within the program to, well, provide the research needed to actually improve knowledge in the space. This is how we organize ourselves. We essentially have 6 research communities. So we do a very large range of things, you can see, framed by governance and equity. We think about transport, energy, and critical minerals within the resource efficiency section. We also have activities on infrastructure resilience. I think Raghav is here presenting in this session. And finally on economics, enterprise, and finance. So these are sort of the research communities where there is a deep conversation about very specific things that, a community of knowledge exists behind each of those. And then we try to bring together those 6 research community with a bunch of cross-cutting themes. So they pick parts out of some or all of those research communities and bring them together in projects, which we deliver collaboratively. So a big effort in system planning and policy. So this is a lot around energy systems, working with governments in various countries around the world on energy planning and pushing that forward into impactful policy. A bunch of other cross-cutting themes, but the critical one today, if I can say, is critical minerals. So that is importantly not just the Cambridge team, although they are amazing, obviously. It brings together all of the other teams in CCG as well. So we have those aspects on this problem and are able to make insights that are basically in any one of those areas. No, not working. Okay, I think John also mentioned this, but just very, very briefly. We do quite a lot of research already on critical minerals, mainly based in Cambridge at the moment, but there are bits and pieces elsewhere, like I say, in Oxford, also in UCL particularly. But we want to do more. So we're looking at the possibilities to apply the knowledge built so far to improve it, doing geospatial, linking the energy side of this picture with the critical minerals side, we think is very important, alongside also infrastructure and transport sides. We want to bring in the finance aspects. How do you finance these well? And the governance, environmental, social, etc. And then there's also the bigger picture is how does this fit into the global supply chains and how do we try to make low-income and lower middle-income countries, put them in a position where they are stronger in terms of their bargaining power on the extraction, but also potentially putting more processing activities in these countries and more value capture in those countries. So I don't want to say any more about this because we have a bunch of great presentations coming up. And first up, we have Matteo. So Matteo is currently an independent consultant, but a background from the IEA and the International Transport Forum, a lot of quantitative modeling on energy and transport and some reflections on critical minerals. So Over to you, Matteo.
Good. Thank you for having me, and thank you for inviting me to present. So I'll be presenting a project that I'm doing through UC Davis. We are not affiliated with CCG, so it's very nice to come here and learn about all of the work you're doing. Also seeing what are the overlaps, areas where we can potentially collaborate as well. I think that's super nice. You'll see in this presentation some similarities, also to the previous presentations, the excellent presentation by Sam and Philip in particular, looking into the demands of critical minerals. So in this project, this generously funded by Quadrature Climate Foundation, we're looking at modeling the demands, mostly from the transport sector, of mostly battery minerals. So lithium, copper, cobalt, nickel, and graphite at the demand side, and then also at the upstream at mines. So some of my colleagues in UC Davis are going in a lot of detail into individual mines around the world to then see, is there an imbalance between future demands and future supply? We're not looking so much at the stuff in between, which is why I'm interested also in being here and learning about the work that you guys are doing on it. Today I'll present to you some preliminary work that I've been doing more on the demand side, and crucially looking at what makes a difference. One of the themes of today is that there's still a lot of uncertainty around future demands. There have been lots of studies that have, by both academia, but also large intergovernmental organizations, that say what future demands will be, that we may not align with supply, but often those demand forecasts are quite different between them. Often it's not very transparent why they're different. So that's why we were funded to do this project, was to get a bit more under the hood of understanding differences between them and which critically are the main factors that determine this future uncertainty. So at the end of this project, we hope to make everything publicly available that can also then be a resource for others to use. So focusing firstly on the demand side, in this study, we're looking at quantifying the main factors that have an influence on future critical mineral demands. And we do this building on a very, very detailed global transport model that I built when I was at the International Transport Forum. So this is used by some governments to align their net zero planning, for example, like Norway, and people aligned to it. It's also used by the Science Based Targets Initiative, large multinational companies in the transport sector wanting to claim that they are 1.5 degree compliant, aligned to the scenarios that are developed from this model as well. So we started looking at what are the main factors that are likely to actually impact future critical mineral demands. The first are travel demands. How much will we travel? With what modes? So this covers all vehicle modes. It covers around 60 countries in detail, plus then aggregated regions for the remainder. And for each of these variables, we can have sort of a high and a low scenario and anything in between. We also look, again, sort of first principles, it's modal shifts away from passenger cars to public transport. Same on the freight side, some different scenarios about what uncertainty there may be there. Obviously, EV uptake is very uncertain. We have policy scenarios for different countries around the world based on their existing market uptake and their stated ambitions. Vehicle size segments, are we going to continue moving more and more towards SUVs? Different markets are moving at different speeds. Will have, or potentially could have, a significant impact on future demands for the size of batteries and things. Battery chemistries we've heard about before. We have different scenarios about, they're mainly informed at the moment by announced manufacturing capacity in different regions by chemistry. Battery sizes, scrappage schemes, can we sort of accelerate the turnover of the vehicle fleet? A couple that we haven't yet touched on yet, but we will do, are BEVs versus PHEVs. Now there's a big narrative about plug-in hybrids coming back. And how might that impact critical minerals? And finally, EV export controls. Again, we're hearing lots of discussion from the governments we speak to of people wanting to maintain critical minerals in-house for circularity. What impact might that have? And crucially, where will critical minerals go at the end of life? We've done quite a lot of work in the past on tracking the flow of used vehicles between countries. And so understanding the age demographics of vehicle fleets within different countries, how long vehicles last there, and where do they go at their end of life, which will then be obviously hugely important for where is that scrap supply of minerals going to be. So for each of these variables, these are the main ones that we look at, we have different scenarios. If you had everything on a high and a low, you could have sort of the two extremes of what your critical mineral demand would be. But that on its own wouldn't allow you to understand which of these actually makes a difference. Which of these is more important than the other? And where is the uncertainty in critical mineral demand actually coming from? So to understand that, you have to come up with a much larger number of scenarios to quantitatively understand which of these makes a difference. So at the moment we have around 288 scenarios. You could have more, you could have less, but the more you have, the more you are able to disaggregate between the individual impacts of each of these levers. Okay, so if we run these, I'll just show you these for lithium, cobalt, and nickel. These are these hundreds of different scenarios, again, which then emphasizes what the uncertainty is with each of these. There's a huge amount of uncertainty for just for these three minerals, but it's the same also then for copper and graphite, which I haven't shown here. We've started also comparing these to other organizations that tell you, the future critical lithium demand will be X. And actually, when you look at it with this scope, actually you see that we need to take that with a bit of a pinch of salt to actually really understand how certain are we with that future demand. We can then also do this with vehicle scrap at the end of life. Run again huge amounts of different scenarios. And again, the timing of future scrap availability is we know is going to happen quite a lot later, but there's still a lot of uncertainty of exactly where that will be and how large it will be. And if we plot those together, we can see that by around 2060, future scrap supply should actually enable us to significantly be able to reduce the amount of primary mineral demand we'll need. If we are able to collect this scrap, recycle it, actually you could get quite close to what new vehicle mineral demands in red would be. But still quite a lot of uncertainty. And if we're trying to actually say, do we have enough supply to meet demand, it's still a huge amount that we don't know. And so I think it's a little early to start declaring alarms that we're not going to have enough, given that we still really don't know very much about the future. Also, I think this is also useful for the private sector, say for a mining company. You're starting to try and figure out, should I open a mine with a certain lifetime? It's very hard to understand what the price environment for the minerals might be in the next 10 to 20 years. Also, if you know that this scrap supply is likely to start scaling up quite a bit in the near future and actually start reducing the demands for primary minerals, I think understanding this in a lot more detail is going to be really important for lots of different stakeholders. So with this, we're able to also then look at where are this demand for new vehicles happening and where is this scrap supply ending up. So we can focus perhaps just on lithium on the left there. So in red is, again, what new vehicle mineral demands are and where it's likely to happen. So you can see that China is, no huge surprise, is likely to be the leader in demands for critical minerals. This shows you the demand and the supply in 2060 as an example. Other regions are likely to be less significant in terms of the overall demand. So again, where is this uncertainty in future demand actually coming from? Lots of it's from the countries at the top. USA, interestingly, because population is still expected to grow more than, for example, in Europe. The other thing that's interesting is where is then the scrap supply actually going to happen? We expect to see lots of the end-of-life minerals ending up in Southeast Asia and in Africa, and crucially, there's likely to be more scrap there than there is new demand. Hard to predict, of course, but so already we can envisage there's going to need to be a huge flow of end-of-life minerals from many of these emerging markets to the regions at the top that have more demands than they're likely to have scrap. Oops, sorry. The other thing then, as I said, looking at all of these different scenarios, we can actually then look at what makes a difference. So these figures at the top, the total shows you the total uncertainty in 2060 for each of these different minerals. Okay, so we said that, say, again, if we focus on lithium here on the left, we have around 0.75 million tons of demand for new cars in the top. Then by decomposing that uncertainty, we can see which of these variables contribute to that uncertainty. Where is that uncertainty actually coming from? Interestingly, travel demand actually still accounts for a very large amount of that uncertainty. We don't know, based on uncertainty in population projections, GDP projections, how many vehicles there will need to be in the vehicle fleet by 2060. Other variables are less important. For example, scrappage schemes, surprisingly, actually don't have that much of an impact on new vehicle demand, a little bit more on scrap supply. Battery sizes actually could have a very big impact. Are we going to keep vehicle ranges constant at today's level? Or are we going to keep battery sizes at today's level? All of this can actually have a very big impact. It also then differs between different types of minerals. So for example, you can see that modal shift from cars to public transport has more of an impact on the uncertainty for cobalt and nickel. Why is that? Is that if we're moving out of cars towards things like buses, we're moving towards chemistries that are more like LFP, and therefore are likely to have more of an impact on copper and nickel than they are on lithium. So by understanding which of these factors actually make more of a difference, we can have a greater understanding of actually how certain we are. If we are confident that we know what travel demand is going to be like, then we can start to actually reduce that future uncertainty a lot. Finally, we can also then look at obviously which are the vehicle types that are going to be important into the future. This again shows you for 2060. Perhaps it's no surprise that cars are likely to be the biggest share of future demand for each of these critical minerals. But I think something interesting is that we expect heavy duty vehicles are actually going to be a pretty substantial part of that as well. Again, for lithium, for example, around 2/5 of future demand for minerals in 2060, we would expect to be from heavy duty vehicles. These are just some initial findings. This is still a work in progress. We're doing all of this on the demand side to understand the uncertainty, but we're also doing it on the supply side for different mines, looking at cost curves, looking at different factors, and then trying to align these of actually how certain are we that there might be some supply and demand imbalances. That's basically what I have for you today. I guess some of the conclusions are that the scrap supply is going to be play a very important role by 2060. There's going to be a huge trade from where vehicles end up at their end of life to the countries of new vehicle production. And yes, we can delve into a lot of that more perhaps in the discussion. Thank you very much.
I want to introduce Raghav. So Raghav Pant is at the Environmental Change Institute in Oxford, coming from a background at an IIT and then Princeton and then University of Oklahoma on risk and resilience analysis. So over to you, Raghav.
Hi, thanks a lot. Thanks a lot, Al, for the introduction. I'm not going to talk about risk and resilience, even though that's my main background. I'm going to talk about the work that we've done in critical minerals within the CCG, which is kind of, I feel like, the biggest collaboration that has happened within CCG that has brought different teams together. And I'm going to talk about a very small component of that project, which is literally 5% of what has been done over here, which is on the transport modeling work that I led. So this is kind of part of this international partnership team of CCG led by Vivian Foster, and this is a report that we have just given to the FCDO. Lily, Laura probably have that on their computers. And the main kind of hypothesis of this report is looking at the possibility of countries in southern and eastern Africa going up the value chain of critical minerals. Because as many of you might already be aware, most of what is being produced in these countries is just the most raw materials and they're just exported, and these countries are not really benefiting. So our study is, the important word of our study is a simulation of the possibilities of kind of going up the value chain. There's a lot of outputs. I'm covering a very small aspect of transport, as I said, because John asked me to concentrate on transport and how the transport model works. And Mateo's presentation is quite useful in terms of now kind of going from this high level supply-demand balance, looking at it very spatially, which is what I'm going to do. So, as we know in the African countries, the African context, these mines are kind of located, and most of the developments that are happening on the transport infrastructure side of things has pretty much been done to transport things from the mine to the port and to the rest of the world. So the transport networks and transport system itself is very integral to the development of Africa. So understanding kind of these transport networks is very crucial. And as lots of studies that speakers before me have spoken about, like critical minerals being more and more important, and just there's a whole growth story associated with with critical minerals. So that ties to transport investments in Africa as well. The last point, as I said, network risk and resilience, that's my core competence and what I've dedicated most of my career on. That's I'm not going to talk about, but that's a big aspect also when we talk about risk and resilience of these supply chains. So we are looking at 6 minerals, cobalt, copper, graphite, lithium, manganese, and nickel across 14 African countries, southern and eastern. And as the graphic over here shows, some of them pretty much are big dominant players in the global supply chain of these critical minerals, such as DRC in terms of cobalt and copper, Zambia, also kind of copper, Mozambique, Madagascar, South Africa, all of them are big players. So one of the things that we kind of want to look at is this question about alternative scenarios of this mineral supply chain and the value chain, and specifically concentrating on the value chain that goes towards the EV battery supply chain. So that's kind of a very kind of, you might say, narrow remit, but kind of as people have said, batteries are, what do they say, 87% of kind of lithium goes into batteries and stuff. So the question that I'm kind of, through my presentation, what I'm highlighting is how do we map key routes for these critical mineral supply chains? How do we think about building future processing sites as we go up the value chain, and what are the transport requirements? And the framework is kind of, this is part of the framework. Essentially what we are doing is we are looking at existing mining locations, and we are projecting future mining locations, and Baptiste Andrew is sitting in the audience, or is he not here? But he's going to talk about this. He's done the work on understanding where the future mines come up. And then understanding kind of what is the requirements to go up the value chain, and the boxes in blue, which is what I'm going to concentrate on. This is where the transport corridors come in, and they enable that upgrade towards the value chain, and using all of that to then understand in the future what will be some sort of cost, tonnage requirements, value addition, carbon emissions, so on. So we have a lot of metrics. I'm going to present a small set of those metrics. One of the things we have kind of grappled in this study is this box of creating global trade matrices for the future, which lots of people spoke about the high level supply demand balance, and this has been a kind of interesting kind of problem to grapple with, creating demand for the new supply that will come out of Africa. So just to kind of go through bits of this, and I have some maps now. Like this is the work led by Baptiste, looking at where we took some data from S&P and other kind of sources, and one of our challenges was looking at it very spatially. where existing, so the map on the left shows existing mines are. So we've literally looked at where these mines are located for these minerals, and as you see the copper belt being prominent. And by 2040, where would these mines be located, and what would they be producing? And as you see with the blobs, kind of the green blobs, especially, there's a lot of graphite coming in Eastern Africa.